we are to determine the characteristic of perpendicular lines. So you have the green line and yellow line. They are perpendicular to each other. And we are to give their respective equation. You have the yellow line as y is equal to m1x plus c1, and green line as y is equal to m2x plus c2. And we are to look at the relationship between m1 and m2. By referring to the diagram, you should know that your m1, the gradient of the yellow line, has a positive gradient, and you have m2, this green line, has a negative gradient. It's moving downwards. So you know the direction of the two slopes. They are the opposite of one another. So if you are to express that mathematically, you have m1 is equal to minus m2. This is not the end because we have to refer to the magnitude. In other words, you are to ignore the sign and just to determine the number itself. So suppose we start from this yellow line, take a length of change in x, and we are to determine its corresponding change in y. So I believe you have this as change in y. So remember this piece of change in y, the length of this change in y, and we are to use the same length of change in x and determine the corresponding change in y in this green line. So if you are to refer to this green line, it has a little bit greater change in y than your yellow line. So that tells us that this green line has a greater magnitude in slope. If you are to see the diagram, you know that by looking at it is more steeper, while the yellow line is less steep and gentle. And how would you express the magnitude in terms of mathematics is that they are the reciprocal of one another. So if you have your m1 as over 1, then your m2 will be 1 over m2. Let's rearrange this formula. You have m1 is equal to minus 1 over m2. If you combine the direction and the magnitude, you should know that m1 is the negative reciprocal of m2. Before we end this lesson, you should see a special point, that is this point of intersection. So if you refer to this intersection point, I normally denote it as the test point. This test point is the point in which my green line and yellow line, they have the same x and y value, so denoted as x0 and y0. And this point will help us to determine our corresponding y-intercept C1 and C2. Thus, we can determine the equation of the two lines. We are to look at an example. So I believe if you are to look at the question, you should have two lines altogether. So the first line in green, I believe the question has shown you the feature. So this line in green should have a slope of -3. So let's label this. And you are to specify one point on this line, that is 2, 5. And if you refer to the second line of the question, you have another line, and that is perpendicular to this green line and pass through the same point, 2, 5. So they should be perpendicular to each other and passes through the same point, 2, 5. And we are to determine the equation of this line. Let's write the general equation of a line in slope-intercept form. So you have y is equal to mx plus c. Since we are specifying the second line, I'm going to put m2 and c2, and the green line gradient as m1. First of all, let's determine m2. So you know that m1 and m2, they are the negative reciprocal of one another. So you have the expression m1 is equal to the negative reciprocal of m2. So since m1 is 3, so negative of minus 3 is positive, and you are to take the reciprocal of 3. And I believe you should get your m2 as 1/3. That's right. Or else, if you are to look at this expression in orange, you are to rearrange it. You are to multiply both sides by m2. So the product of your two gradients of the perpendicular line is equal to -1. And this equation is what we commonly use to determine the slope of the perpendicular line. So let's substitute m1 to -3. I believe you should get -3 m2 is equal to -1. And we divide both sides by -3. And you should get -1 over -3. That should give you 1/3. It's the same by taking the negative reciprocal of m1. So we have determined our m2 is equal to 1/3, and you are to substitute m2 with 1/3. And we are now to determine our c2. So how would you determine the c2? Is that there is a test point being given, right? 2, 5. And you are to use this test point. You are to substitute your x and y with 2 and 5 respectively, and that will leave your C2. You are to solve for C2. I believe you should get your C2 as 13/3. And let's substitute our M2 and C2 back into our general equation. You have y is equal to M2 1/3 x plus C2 13/3.